One single drawing is usually not enough to describe a complex three-dimensional architectural object. So more often than not, architects use combinations of drawings or views, plans, elevations, sections, and details to communicate their ideas. Whether those drawings are arranged on the same page or in a set of sheets, they need to be organized in a way to tell a cohesive story. So today I'm going to talk about this organization. After watching this video, you will have a better idea of how architectural views are interconnected. You will be able to navigate sets of drawings and even put together your own sets, like this one. By the way, this set was created for the purposes of this video. The project and the drawings in this set are made up. Before we jump into the drawings themselves, it's important to understand that each technical drawing on a sheet or in a set needs to have a unique address. Let me explain. A typical architectural sheet would have a title block on the right side or at the bottom. The design of a title block would vary by architect, but all title blocks have roughly the same components. Architect's name, logo, contact info, and sometimes a place for an architect's stamp. Project name and address. Submittal and revision history with dates. And finally, sheet information, sheet title and number. Regardless of whether the title block is at the bottom or on the right, the sheet number will land in the bottom right corner. Here's a bonus question for you. Do you know why convention puts the sheet number in the bottom right corner? That's because when you flip through thick bound sets printed on large format paper, that's the corner that's the closest to you. Having all the identifying information in that corner allows you to find the correct sheets faster without having to flip through the pages. So we have the sheet number. It can be in any format. It can be 1 or one of, say, 7. In a technical set of drawings, it would be something like 101, or more commonly, A101. A stands for architecture, to distinguish from other disciplines, like landscape, structural, or electrical, to name a few. A sheet may have one single drawing, or a collection of drawings. Each drawing on a sheet should have a label. The label usually contains a drawing title, scale, and a drawing number. If a sheet contains 4 separate drawings, they will be numbered 1 through 4, or A through D. So that's how we arrive at a drawing address. The address of this drawing would be 3/A101. It is also common to represent it like this in a circle, with a drawing number at the top and a sheet number at the bottom. Now that we understand the system for referencing a specific drawing, let's look at how architectural drawings are interconnected. Typically, the first and the most important architectural drawing is a plan. A plan is a primary comprehensive guide that defines a building's spatial layout. But it also typically serves as the central reference point in a set. It references all other drawings. Here's a plan of a simple shed. It is drawing 1 on the sheet A1. The shed has one enclosed space with a restroom, a porch, a double door, and 2 windows. The plan gives us a pretty good idea of what kind of shed it is, but it tells us nothing about the height of the structure, the shape of the roof, or what it looks like. We need more drawings. We need elevations. Here's a sheet of elevations. Elevations are side views of a building, and they're usually second in importance and in order in a set of architectural drawings. Our shed has 4 sides, so we have 4 elevations. You can see that our elevations are arranged on the sheet A2, and each has a label. Now we can reference each of these elevations on the plan using a special elevation symbol. This is a standard symbol for an elevation, where the top number is the number of the drawing, the bottom number is the number of the sheet, and the arrow is pointing towards the side of the building that the elevation is depicting. Let's position our 4 elevation references on the plan. Elevation 1 is the front of the shed, Elevation 2 is the right side, Elevation 3 is the back, and Elevation 4 is on the left. Our understanding of the structure is still incomplete without building sections, but luckily we have a sheet of sections, A3. Sections usually follow elevations in a set. The standard symbol for a section is this. The thick dashed line indicates the cut through the building, and the arrow points in the direction that we're looking in. Let's position our section references on the plan first. Section 1A3 cuts the shed east-west. And Section 2A3 cuts the shed north-south. We can also place the same section references on the elevations. To recap, we start with a plan view that references elevations and sections. Then we have elevations that can also reference sections. And then we have sections. All of these drawings are drawn at the same scale, usually 1/8 of an inch or 1/4 inch. The next type of drawings jumps from this scale to a larger scale that shows more detail. The umbrella term for this type of drawing is large-scale drawings or enlargements. An enlargement is represented on a drawing with an enlargement bubble, also known as a callout. The cool thing about enlargements is that you can enlarge any portion of any drawing. You can enlarge a portion of a floor plan. For example, this scale doesn't allow us to dimension all the equipment and accessories in the restroom, so we can create an enlarged plan only of the restroom that's double the scale and place it on the sheet A4. We can create an enlargement of an elevation. For example, I have a very fancy window in my shed that I want to represent in more detail. I will place this enlargement on sheet A5. I can also enlarge sections to have a closer look at wall sections, shafts if I have them, or any other transitions that are best represented in a section. I will put all of my wall sections on a new sheet A6. The last view type that I want to talk about is details. While enlarged drawings typically zoom in from initial plans, elevations, and sections twice, details are very large-scale zoom-ins. They're usually drawn at 1 inch equals to 1 foot, 1.5 inch equals to 1 foot, or even 3 or 6 inches equal to 1 foot scales. You need to have as many details as necessary to convey to a builder how you want your design constructed. A simple shed may have 1 sheet of details, while some large or complex designs may have hundreds upon hundreds of details. Details can be referenced from any other drawing using the same callout bubble as enlargements. Or you can use a little section symbol if your detail is a view perpendicular to the referencing view. Alright, that's the basics of how architectural drawings are organized and referenced. This basic system can be adapted to each unique project. Quite frankly, there is often as much design thinking that goes into organizing a nice and cohesive set of drawings as into designing a building itself. Hope you found this video useful. Happy drawing!